Hello students, welcome to IMS GATE Academy Gate Score Booster session of Network Theory subject. This particular subject is common for three branches: EC, Electrical and Instrumentation, right? So I hope all of you attended regarding Gate Score Booster regarding digital circuit subject earlier. Whoever not attended, especially the students whoever belong to EC, Electrical, Instrumentation and even Computer Science, those students can watch. We have done two sessions regarding Gate Score Booster regarding digital circuit subject. So those two sessions you can watch whenever you get the time. Okay. So this particular session, in this particular session, we are going to discuss the first chapter and second chapter of network theory subject. Regarding these two chapters, whatever variety of questions related to first and second chapters of network theory subject, that I am going to cover in this particular session, right? So tomorrow also we will be having one more session. In that particular session, we will be discussing regarding remaining three chapters of network theory subject. Related to remaining three chapters, we will be discussing variety of questions. Okay. So in today's session and tomorrow's session together regarding network theory subject, we are going to discuss variety of questions. Definitely whoever attend these two sessions, definitely each and every student will be getting the confidence and in order to get very good marks in the upcoming GATE exam regarding network theory subject. Okay. Yeah, good evening Mathan, very good evening one and all. Okay. So all of you quickly share this video link with all of your friends so that they also will attend this session in live and they also will get benefited from this particular session. Yeah, whoever visiting our YouTube channel very first time, kindly subscribe our YouTube channel and then click on the bell icon so that you will be getting instant notifications, right? All of you kindly like and share this video link with all of your friends quickly. Yeah, this is the first question regarding today's session. All of you give a try. In this particular question, you are having the capacitors. With respect to these two terminals, you have to find the equivalent capacitance. Yeah, just observe in this particular question, you are having capacitors. Okay. So if you closely observe, then only you can identify that which capacitors are contained in parallel or series, etc. And then you can start solving or simplifying. Okay. Say for example here, for the time being, I am labeling this particular node as A. Okay. Otherwise, I will use another alphabets, like I am using this one as P and this node I am labeling as Q. Okay, and this node I am labeling as R. PQR I have labeled. Okay, now just observe, the moment I have labeled this is Q, this node and this node all are same only. All these points are same only. Yes or no? So that means the same point Q. That means between R and Q you are having 1 microfarad. Okay, between R and Q you are having 2 microfarad. Yes or no? You can observe here. Between R and Q, you are having 1 microfarad in this path, and in one more path, you are having between the same terminals R and Q, you are having 2 microfarad. That means these two are contained in parallel. Yes or no? These two are contained in parallel. So whenever resistors are contained in parallel, okay, whatever the formula you might be using, that kind of similar formula or similar format you can apply when capacitors contained in series. Okay, but here capacitors contained in parallel. Here you will be getting the formula similar to when resistors are contained in series. Okay. So that means whenever resistors are connected in series, we can add the resistors like that. Here when the capacitors are connected in parallel, we can add the capacitors. Okay, right. So here 1 microfarad and 2 microfarad both are connected in parallel. That means here we can add the respective capacitances. Okay. So 1 microfarad plus 2 microfarad, that is 3 microfarad. 3 microfarad, right? So this is the capacitor you got with respect to the terminals R and Q. With respect to the terminals R and Q after doing the simplification. Okay. Now, whatever currently you are having, okay, the remaining part of the circuit, okay, just for reference I am drawing here. Between P and R, between the terminals P and R, we are having one capacitor. Capacitance value is 1.5 microfarad. 1.5 microfarad, right? Between R and Q, just now we got the simplified capacitance, equivalent capacitance, we got 3 microfarad. Right. So this is the terminal Q. Now you can observe between this point both are same, P only, right? So between P and Q you are having, between P and Q you are having 2.5 microfarad, right? Between P and Q, you can observe this is the, you are having one capacitor, one terminal is at P, another terminal is at Q. Okay, between P and Q you are having 2.5 microfarad. Okay, now if you observe here between P and Q, here this is one path, right? Here in this case these two capacitors connected in series, right? These two capacitors connected in series. Now here just I am mentioning like 1.5 microfarad is in series with 3 microfarad. Now here capacitors connected in series, the formula you will be getting with respect to resistors connected in parallel. Okay, so that means here equivalent capacitance you will be getting 1.5 micro into 3 micro divided by sum of these two. Okay, 1.5 micro plus 3 micro, like C1 C2 divided by C1 plus C2. So here you can observe 3 into 1.5, that is 4.5 micro square. Okay, here 1.5 plus 3, that is 4.5 micro. So here 4.5 is getting cancelled, micro one time is getting cancelled, so you are getting 1 microfarad. Okay, after doing the simplification of these two resistors, these two capacitors, after doing the simplification of these two capacitors, here we are getting equivalent capacitance as 1 microfarad. Okay, now between P and Q if you observe, you are having 1 microfarad and 2.5 microfarad, both are connected in parallel, right? So regarding parallel we already discussed, whenever capacitors are connected in parallel we can add the capacitances, okay, in order to get the equivalent capacitance. So now here I am writing so here 1 microfarad and 2.5 microfarad both are connected in parallel. So that means here we can add 1 micro with 2.5 micro. That means we are getting 3.5 microfarad. 3.5 microfarad. This is the equivalent capacitance between the terminals P and Q. So answer for this question is option A. Yeah, answer for this question is option A. I hope it is clear for everyone. If you are having any doubt regarding this question, you can mention in the chart. Here, generally, majority of the students, even though they know the formulas, but while they are attempting this question, they might be doing silly mistake. What silly mistake here generally students are doing? With respect to resistors, inductors, what are the formulas you are having? Similar formula you may apply here, but exactly opposite you are getting. Yeah, Ashok, you can join our Telegram channel. Regarding that particular link, it is already provided in the description of this particular video. Okay, so you can join our Telegram channel. Whatever we are writing here during our live class on the digital board, this particular lecture notes we will be sharing in the PDF form after the lecture over. Okay, right. So I hope it is clear for everyone regarding this question. Okay. So I am just giving one important update for all the GATE 25 aspirants, okay, whoever not enrolled at our IMS GATE Academy. Here at our IMS GATE Academy, we are having test series plus program, right? So all of you, like whoever not enrolled at our IMS GATE Academy, this is the time you people have to solve good number of questions and you can check your confidence regarding what are the subjects you thoroughly prepared till now, right? Because here with the help of test series, you can check regarding whichever concepts you are very much strong, in which concepts you need to further revise or where you are doing the silly mistake, etc. So in order to get that kind of exposure, and most important thing, in order to manage the time, in the given time, how to maximize your score, that is also most important. So here in the test series plus program, you are getting 130 plus online tests, which includes with respect to every subject. For chapter level, we are having the test that is called chapter test. Similarly, subject wise, for every subject we are having like basic subject test and then advanced subject test. After that we are having even multi-subject test as well. After that we are having all the mock tests, okay, which all together you are having 130 plus online tests. And in addition to that, you are getting last 33 years GATE PYQs along with the detailed solutions. Okay, with respect to maths and general aptitude, you are getting with respect to 6 branches like EC, electrical, instrumentation, computer science, mechanical, civil, right? So all the 6 branches, previous year GATE questions along with the solutions. And with respect to your technical, okay, if you are from EC, accordingly EC technical part, you are getting the previous 33 years GATE questions along with the solutions, like that with respect to other branch, okay, right? And you are getting the doubt solving portal and even other features, right? So for all, I am recommending this one for all the students who are not enrolled at our IMS GATE Academy. I am recommending this test series plus program. So currently offer is running, 20% offer is there. So regarding this particular link, already provided the Google form, it is available in the description of this particular video. Whoever not yet enrolled for this test series plus program, kindly enroll and please share this valuable update to your friends and juniors, whoever targeting for GATE 25 exam, okay. And one more important update, whoever currently in the second year or third year BTech and whoever want to write the GATE exam in the like upcoming years like 2026 or 2027, etc. So you people can kindly enroll for our live online program at our IMS GATE Academy. So all these are the features regarding our live online program. So regarding free counseling session link also provided in the description of this particular video. Whoever interested, they can kindly click on the link and you can fill the form. Our counselors will discuss in detail about our program features, okay. Right. So this is the next question. All of you give it a try. Yeah, Ashok, you can solve in that method also, but actually that is not required. Say for example, in whichever question, without applying star to delta and delta to star, okay, if you can easily solve with the help of parallel connection and series connection, accordingly you can do it. But wherever that kind of simplification not possible, then if it is required either star to delta or delta to star, you can apply. But even if you are solving the previous question with the help of like star to delta, you have done conversion, okay, but final answer you will be getting the same. This is a simple question, all of you can give a try. So here in this question you are having the voltage waveform, okay, and here you are having the choices regarding the current waveform. You read the question, you are having 100 microfarad capacitor, you are having one capacitor, the capacitance value is 100 microfarad, across it the voltage they have given, voltage waveform they have given, and they are asking regarding the current waveform with respect to that capacitor. Okay, so I hope all of you know one relation regarding voltage and current with respect to the capacitor. Okay, so the formula is with respect to current and voltage. I hope all of you know this formula. The current flowing through the capacitor, say for example I of t equal to C into dV by dt, C into dV by dt. Okay, for generalized case I am writing like voltage across capacitor is Vc of t. Okay, now this is the basic formula, and in this question they have given capacitance value as 100 microfarad, 100 microfarad. Now that value can substitute. After that you have to perform the differentiation with respect to your voltage. Okay, now in this question if you observe, in the interval 0 to 1 you are having one straight line, in the interval 1 to 2 you are having like constant, and in the interval 2 to 3 you are having straight line which is like falling. Okay, here it is like rising and then constant then falling. Okay, now for each interval you have to perform the differentiation, that's all. Okay, I hope whoever good at regarding differentiation operation, they can easily solve this question without using pen and paper. The calculation is very simple, that you can do in the mind level as well. Okay, right, just observe here. First and foremost you can observe like in the interval 0 to 1, in the interval 0 to 1 millisecond. Okay, so here you are having voltage pattern is a straight line which is passing through origin, right? So you will be getting y equal to mx format, y equal to mx format. Okay, right. So here in the interval 0 to 1 you will be getting for t lies between 0 and 1 millisecond. So directly I am writing dVc of t by dt. Because you are getting one straight line, so y equal to mx format, when you perform the differentiation you are getting the slope only, right? So with respect to y-axis or voltage axis, 6 minus 0, see here second this point 6 minus 0, and accordingly here 1 millisecond minus 0, 1 minus 0 millisecond. So from here you are getting 6 divided by 10 power minus 3, 6 divided by 10 power minus 3. Okay, right. Next, now you can find out the corresponding current. I of t equal to C into, C value is 100 micro into dV by dt. Just now we got 6 divided by 10 power minus 3. So here micro you can write as milli into milli. Here 10 power minus 3 is nothing but milli. 1 milli is getting cancelled, so you are getting 600 milli. 600 milli units are ampere. Okay, so 600 milliampere you can observe. 0 to 1 millisecond, 0 to 1 millisecond, here 6 milliampere, so this is not correct. Okay, next 0 to 1 millisecond, 0 to 1 millisecond, here 6 milliampere, this is also not correct. Okay, Next, 0 to 1 millisecond, 60 milliampere, that is also not correct because here 600 milliampere, right? So only one choice is there. In the interval 0 to 1 millisecond, 600 milliampere. So option D is the correct one. Suppose if you are having two choices in the same interval 0 to 1 600 milliampere, after that you have to analyze among those two choices or three choices, whichever is really correct. But for this question, the moment if you analyze with respect to first interval, straight away we can choose option D. Okay. Yes, very good. What is your name? Test. What is your name? You got option D. Yes, option D is the correct answer for this question. Just mention your name. Okay. Next, in the interval 1 to 2, here you are having 6. Okay. Since it is a constant, derivative of constant will be what? 0. Yes, definitely here it is satisfying in this particular interval. Okay. Next, in the interval 2 to 3. In the interval 2 to 3, just for verification, we are continuing further. Okay. Whether we are really getting or not. So for the interval 1 millisecond to 2 millisecond, here dvc of t by dt will be 0. So accordingly here the current value I of t will be 0. Okay. Next, in the interval for 2 millisecond to 3 millisecond, okay, for the interval 2 millisecond to 3 millisecond, yes, Ravi, okay, fine. 2 millisecond to 3 millisecond, in that interval, you can consider the slope dvc of t divided by dt. So here 0 minus 6 divided by 3 milli minus 2 milli. So here in this case you are getting minus 6 divided by 1 milli. So that means here you got 6 divided by 1 milli, here minus 6 by 1 milli. That means if you proceed further, here plus 600 milliampere you got, here you will be getting minus 600 milliampere. So direct step I am writing IC of t equal to minus 600 milliampere. Okay. So that same thing here you are having in the interval 2 to 3 minus 600 milliampere. Okay. So for this question, the moment if you analyze in the first interval, directly we can choose option D. Okay. Yeah. Next question, all of you give it, right? In this question, you have to find the equivalent resistance. Ashok, you are from which branch? This is simple question. Whoever do silly mistake, they may get the wrong answer. But if you carefully observe the connections, then definitely you can get the correct answer. Okay. So here in this question, if you observe, here this point is same as this point. That means this point is A. This node is nothing but A, right? Yeah, Ravi, you can cross check. You might have done silly mistake. That is the reason you are getting different answer. Okay, just to avoid the silly mistake, no issue at all. No issue at all. In order to avoid the silly mistakes in the GATE exam, whenever you are getting the network or circuit like this, just make the labeling just for your reference, so that you will be coming to know which resistors are contained parallel, which resistors are contained series, etc. Okay, here this node is A, this node is B, right? This node is B means this node also same, B only, correct? All these nodes are same only, B node. Okay, next, here this particular node I am labeling as, say for example, C. Okay, since this is C, obviously this is C. Okay, now here just for reference I am labeling this is a B, same B, and here it is C, and this point also C only. Okay, right. Now here this is the first observation point. Once if you observe like this, here's between A and C, 6 ohm resistor is there, 4 ohm resistor is there. Here these two are contained in parallel. These two are contained in parallel, right? So 6 ohm parallel with 4 ohm. So that means you are getting 6 into 4 divided by 6 plus 4. 6 4s are 24 divided by 10, that means 24 divided by 10, that is 2.4 ohm. Right? 24 divided by 10, 2.4 ohm. Okay. Now just closely observe. Here after doing the simplification, you are getting one equivalent resistance that is existing between terminals A and C. Now between terminals C and B, here you are having 2 ohm resistor. Between terminals C and B, you are having 8 ohm resistor. So that means here 2 ohm resistor and 8 ohm resistor, these two are contained parallel. That is the most important observation point in this question. Okay. See, after finding the equivalent resistance between A and C, you got between A and C one resistor. Okay. With respect to C and B, you are having two resistors, both are contained parallel. Ravi, have you done like this or any silly mistake here? Just cross check once. Here, this is the first observation point, and then here 2 ohm and 8 ohm, both are contained parallel. 2 ohm and 8 ohm, both are contained parallel. So that means here you are getting 2 into 8 divided by 2 plus 8. So 2 8s are 16 divided by 10, that is 1.6 ohm. 1.6 ohm. Okay. Now what you got? Here after doing the simplification, between A and C we got one resistor. Okay. Next, after doing the simplification, here we are getting between C and B. Yes or no? Okay, just for reference I am drawing the circuit. Okay, between A and C we got 2.4 ohm. Right? Okay, between C and B we got 1.6 ohm. Okay, now these two resistors are contained in series. So RAB equal to RA here 2.4 plus 1.6. So that means you are getting 4 ohm. 4 ohm, that's all. Okay, all of you can cross check. Still, if you are having any doubt or confusion, you can mention the chart, I will clarify. So here the first and foremost observation, these two are contained parallel, we got the equivalent resistance 2.4 ohm. And then these two are contained parallel, equivalent resistance we got 1.6. After that, between A and C, one resistor, between C and B, another resistor, these two are contained in series, that's all. Okay, next question. Here also how to find the equivalent resistance. Okay, I will be giving 2 minutes time, all of you give it a try. In whichever method you are comfortable, you can do it. Here in this question, we have to find the equivalent resistance between the terminals A and B. In order to get equivalent resistance, whatever the methods you have learned in the first chapter of network theory subject, accordingly you can go ahead. Yeah, this is a very interesting question. Generally, many of the students, while solving this question, they may apply star to delta. Okay, they may apply star to delta or delta to star. Okay, but without, of course, even if you apply star to delta, this star network you can convert into delta, or this delta network you can convert into star. Okay, that is one method. Whatever the final answer you are getting with respect to equivalent resistance between the terminals A and B, the same answer you can easily get if you closely observe this particular circuit and if you are able to draw equivalent circuit, and after that if one condition satisfy. Okay, what is that condition? That I am keeping suspense as of now. You will be coming to know in short. Okay, provided if that condition satisfy, then without converting star to delta or delta to star, you can easily get. Okay, right. So here whatever the circuit you are having, here already the nodes A and B they have given. Okay, so that means this node point is B, this node also same B. Okay, just for reference I am labeling, and then this node for the timing I am labeling as C, and this node I am labeling as D. Okay, now whatever the circuit here you are having or network, that one for the timing I am drawing like this. Okay, so here between A and C we are having 6 ohm. Yeah, this node I am labeling A, this node I am labeling as C. Okay, between A and C we are having 6 ohm resistor. So the moment I have drawn one component or resistor, after that I am putting tick mark so that whether we covered all the resistors here in this diagram or not. Okay, between A and C we are having 6 ohm, and between C and B we are having 6 ohm. Between C and B we are having 6 ohm. Okay, next between B and D we are having 18 ohm. Between B and D we are having 18 ohm. Okay, this resistor also we have connected. Then between D and A we are having 18 ohm. Okay, between D and A we are having 18 ohm, that I connected. Okay, now here between D and C or C and D we are having 6 ohm. Yes, now just observe whether we have connected all the resistors or not. Yes, we have connected. Between A and C 6 ohm, C and B 6 ohm, B and D 18 ohm, then D and A 18 ohm, then C and D or D and C 6 ohm. Now in this question, according to the question, we have to find out the equivalent resistance between the terminals A and B. Between the terminals A and B, we have to find out the equivalent resistance. Okay, with respect to the terminals A and B, we have to find out the equivalent resistance. Yes, now just observe. Now just observe what you are getting. Whatever the given circuit or network you are having after I represented in this particular format, what is your observation point? Initially, you may not thought that we can draw the equivalent circuit in this format, but at least after seeing this particular format, at least you might be noticing one important observation. What is that? See here, with respect to the terminals A and B, we have to find out the equivalent resistance. Okay, say for example here, if you connect one voltage source, okay, then definitely because of that voltage source, current will flow in this particular circuit between the terminals A and B. And if you are taking the ratio of voltage and current, that is nothing but what? Equivalent resistance, correct? Now, when you connect one voltage source here between the terminals A and B, that time what will happen? Here 6 ohm, 18 ohm. When you multiply these two, okay, you are getting 6 into 18, and similarly here 6 into 18, that means opposite arm resistances product, it is matching. That means what? This particular circuit is what? Balanced bridge, right? Balanced bridge. Okay. So here in this case, the given circuit is balanced bridge. How we are saying it is a balanced bridge? Because the product of opposite arm resistances 6 and 18 and similarly 6 and 18. Okay, whenever it satisfies like this, then in this case, whatever the branch here you are having between the terminals C and D, between the terminals C and D, if you are using galvanometer, the deflection is what? 0. That means here in this particular branch there is no current flows. Okay, in this particular branch there is no current flows. So if no current flows, that means voltage across this particular 6 ohm is how much? 0 volt. 0 volt. Okay. See, with respect to your convenience, with respect to 0 volt, if you want, you can make like short. Okay, or with respect to 0 ampere, you can 0 ampere means what? In this particular branch, there is no current flows. Okay. So based on your convenience, in any way you can represent the equivalent circuit whenever you are having practical resistor or finite resistor value. Okay. In that particular resistance path, because of current 0 ampere, you can consider as open circuit. Or by using Ohm's law, you are getting 0 volt. That means with respect to 0 volt, you can say the terminals C and D are like shorted. You can consider equivalent circuit as short. Based on your convenience, you can follow any method. For the timing, I am considering like open circuit. With respect to 0 ampere, we can say open circuit. With respect to 0 volt, short circuit. Okay. But for the timing, I am following like this. Later in your free time, you can consider short circuit. Definitely equivalent resistance is going to remain same. Okay, right. This is one of the most important conclusion point regarding this particular finite resistor. Okay, right. Now, the moment here you have removed the 6 ohm resistor from the circuit, then definitely C and D terminals, that particular path is like open, right? Now, when you are saying here in this branch 0 ampere, that means what about this 6 ohm and 6 ohm? How these two are connected? Series only, yes or no? See, whatever the current is flowing in this branch, the same current is flowing because here 0 ampere. Similarly here, whatever the current is flowing, the same current is flowing. That means here 18 ohm and 18 ohm. These two are connected in series, that's all. Okay, this is the one important observation point. The moment in this branch there is no current flows, that means these two resistors connected in series. These two resistors connected in series. Okay, right. So here just I am writing the direct step. RAB is equal to, here in this branch 6 ohm connected in series. That means 6 plus 6. Okay, that is one resistance, equivalent resistance, and one more path. These two are connected in parallel. Right, here 18 plus 18. So that means you are getting 6 plus 6 is 12 in parallel with 18 plus 18, that is 36. So here we can write 12 into 36 divided by 12 plus 36. 12 into 36 divided by 48. So here 12 4 times and then 4 9 times. That means you are getting equivalent resistance as 9 mho. Equivalent resistance as 9 mho. Okay. Later in your free time, just you can consider C and D terminals are shorted, then these two are contained parallel, these two are contained parallel. After that you can find equivalent resistance as like series combination. Finally you will be getting same 9 ohm only. Okay. So how many of you liked this question? How many of you liked this question? Whoever liked, you can mention in the chart. It is an excellent question. Whoever watching this particular session in the later in the recorded form, they can mention, whoever liked this question in the comment section, you can mention question number and then mention excellent. Whoever liked this is a very good question and interesting question. Okay. You can mention your rating. For the timing I have given 5-star rating. Whichever rating you want to give for this particular question, question number 4, you can mention in the comment section. Mention the question number and then you can give the rating. Okay, I hope everyone liked this question. Okay, now we'll go, I will show the next question. All of you give a try. In this question also you have to find out the equivalent resistance. Here in this question you are having the terminals A and B here. With respect to terminals A and B, you have to find out the equivalent resistance. Ujjwal, is it clear? Ravi, is it clear regarding the previous question? Yes, very good, Ravi, very good. Yeah, in this question also sometimes few students may apply this delta into star conversion, but actually not at all required. Okay, see, wherever we cannot solve the question with the help of series connection or parallel connection or maybe combination of that, or with the help of balanced bridge like previous question, wherever like all these possibilities not at all, matlab you cannot apply even with any of these possibility, then definitely without star to delta, delta to star, we cannot solve. If you feel like that, then definitely you can apply. Okay. So here in this question, if you observe just like earlier questions, okay, first of all you can put the labeling so that from there you are getting the clue. Here this terminal is A, right, and this terminal also same A only. A only. Just for reference I am mentioning, all these points are same, right. And here this point is B, and that means this point also same B only. Okay. Now here this node I am labeling as suppose C. This node I am labeling as, if you want you can label D. Okay, no problem. Now here you can observe between A and C. Okay, this node D just I am removing. Okay, between A and C. Between A and C you can observe these two resistors are contained in series. 5 ohm, 5 ohm, both are contained in series. In series we can add the resistors 5 plus 5, that is 10 ohm. Dash step I am writing. Now once if you got equivalent resistance as 10 ohm, now these 2 points are same, okay, and here you can observe between A and C, here we are having 10 ohm resistor in this path, and one more path between the same terminals A and C, we are having 10 ohm resistor. That means these two are connected in parallel, right? So 10 parallel with 10, that means 5 ohm. Okay, here I am writing just for reference, or up to here I am keeping like this. Yeah, up to here I am keeping 10 parallel with 10, that is 5 ohm. Right? So now you got between A and C this entire equivalent resistance as 5 ohm. Now that 5 ohm resistor and this 5 ohm resistor both are connected in series. That means 5 plus 5, that is 10 ohm. Okay. Now in this path you are having 10 ohm, and in this path you are having 10 ohm. Both are connected in parallel. So once again here you are getting like this, RAB equal to 10 parallel with 10, that is 5 ohm. Okay, just by applying series and parallel you are getting the equivalent resistance. No need to use pen and paper. That much silly question, but only thing you should have that visualization. Okay. So the final answer for this question is option B. Right, I hope it is clear for everyone. Next question, this is also very interesting question. All of you give it a try. I will be giving 2 minutes time. Even though for some of the questions, even though you might have done earlier silly mistake, no issue, at least you can just cross verify. Here at least this is the deciding question. Okay, all of you try to get the correct answer. Regarding resistors and inductance, the kind of series connection equivalent formula, and similarly with respect to parallel, whatever you are getting with respect to resistors, similar format you will be getting with respect to inductors. Okay, in series and accordingly corresponding parallel. Only for capacitors you are getting exactly opposite. Yes, very good Ravi, excellent, excellent. So here in this question with respect to the terminals A and B, we have to find out the equivalent inductance. Okay. So just for reference, just like the earlier questions, I am labeling the node. Here this point is same as this point, okay, and that is same as this point also, because here you are having one line and here also one line. That means here all these points are represented same only. Just for reference I am putting same node A. Okay. Similarly here this node, this node, this node, all are same only. B, node B. This is the first and foremost observation. Once if you catch this one, after that you can easily solve this question. Okay. Now if you carefully observe, okay, just for reference here I am labeling some other node. Say for example, this is C, this is D. Okay, right. So just if you closely observe, between node C and A, you are having 1 Henry inductor. Okay, between C and A, 1 Henry inductor. Between C and A, 1 Henry inductor. That means here you are having 1 Henry inductors 3. All the 3 1 Henry inductors are contained between the terminals C and A only. C and A only. Yeah, Teja. So since you have completed the syllabus, okay. So say for example, what you can do, like whatever the syllabus you have completed, so just you can have the like one quick revision, every formula subject wise you can have one overview, like whatever the important points are there, formulas are there. After that you can apply the you can attempt the mock test and all. Okay, and whatever the sessions here in our YouTube channel we are doing, whichever sessions are related for your branch, accordingly you can watch also. Okay, and if you are attempting the mock test, what will happen, like there you can check like whichever subjects you felt like I am very much strong, whether you are really strong in those subjects or you are really strong in those areas or not. Okay, so you before attempting each and every mock test, you can just cross check, and first and foremost you do the revision from your class notes only. Just for attempting that particular mock test, how much time you can devote, accordingly you can do one quick revision and then you can attempt the mock test. After that, through the mock test, what is happening, whichever concepts or whichever subjects you are very much strong, with the help of that test you are coming to know whether you are really strong in that or not. Suppose example, just like few questions, some students are having the misconception while reading the question or while answering, or even some students may stuck while solving the question. So at least you are identifying those areas. After attempting the test, whatever the learnings are there, whatever the mistakes you have done, try to learn, make all the points as the learnings. So with that learnings, while going for the next mock test, try to make sure that you are becoming perfect. In this manner, like you can keep some buffer time. Like I mean to say, if you want to attempt the full length mock test, at least you can keep in a week 1 mock test will be sufficient on an average. Okay, like that you can keep, so that there will be the momentum. Okay, that is a good practice, because through the mock test also you are getting two-way benefit. One benefit is you are getting the confidence in whichever subjects or in whichever concepts you are strong, and through the mock test at least you are getting the awareness that in whichever subjects or in whichever concepts you are little bit facing the challenge. So at least in that selected topics you are becoming you can do the revision before you are going for the next mock test. Okay, I hope it is clear for Teja. Right. Okay, so here between C and A you are having 1 Henry, 1 Henry, 1 Henry. All the 3 1 Henry inductors are connected in parallel between the terminals C and A. Right. So that means here equivalent. Okay, just for reference here I am writing between the terminals C and A, we are having 1 Henry inductors, we are having 3, all the 3 1 Henry inductors are connected in parallel, right? Okay, I hope all of you know whenever resistors are connected in parallel or inductors are connected in parallel, especially when you are having equal value. Okay, so you are getting L equivalent is nothing but L divided by 3. Okay, right. So that means here you are getting 1 by 3 Henry, 1 by 3 Henry. Okay, right. Similarly here between the terminals D and B you are having 1 Henry. Okay, here between the terminals D and B 1 Henry, between the terminals D and B here you are having 1 Henry. Right. Once again here all the 3 1 Henry inductors are connected in parallel. Once again same. Okay, directly I am writing, I am not writing in detail. Okay, between the terminals D and B, once again you are getting 1 by 3 Henry. 1 by 3 Henry. Okay, now up to here everyone will be doing correct, but after that still some students may do silly mistake. Okay, here whatever you got, now you can place equivalently, okay, the connections. So as of now what you got? between the terminals C and A, we got 1 by 3 Henry. Okay. Here we got 1 by 3 Henry. Here also we got 1 by 3 Henry. After that, here we are having 1 Henry and here we are having 1 Henry. Okay, right. So just I am representing like this. Sorry, here we are having inductors. So between the terminals C and A, we got 1 by 3 Henry. Right. Okay, up to here we have done. Right. Just for reference, I am mentioning like this. Okay. Next, between A and B, we are having 1 Henry. Between A and B, we are having 1 Henry. Okay. Next, between B and D. Okay. Between B and D, after doing simplification, here we got once again 1 by 3 Henry. Henry, right. Okay, next, up to here we have covered everything. Now here one more inductor is pending. Okay, so just for reference, here I am putting tick mark. Between A and B we covered that 1 Henry. Okay. Okay, or otherwise I will put round. Okay, next, here between C and D we are having 1 Henry. Between C and D we are having 1 Henry. Between C and D we are having 1 Henry, right. Here ultimately we have to find out the equivalent inductance between A and B. So just for reference, here I am putting like this. Between A and B we have to find the equivalent inductance. So that means you should do in such a way that regarding the simplification or minimization in such a way that you have to keep the arrangement finally you should get with respect to the terminals A and B, that's all. Okay. Now if you closely observe, between terminal A and B with respect to this one path, you are having 1 Henry inductor. Okay. Another path what you are having between A and B, you are having one more path like this. Okay. Now 1 by 3, 1 by 3. These three are continued in what? Series. These three are continued in series. Okay. I hope all of you are getting the clarity. Here 1 by 3, 1 and then 1 by 3. These three are continued in series. Okay. So 1 by 3 plus 1 plus 1 by 3. So you can do simplification. You are getting 2 by 3 plus 1, that is 5 by 3. 5 by 3 Henry you are getting, right. That 5 by 3 Henry you are getting with respect to terminals A and B in one path, right. In another path you are having 1 Henry. Both are continued in parallel, that's all. So 1 Henry parallel with 5 by 3. So here 1 into 5 by 3 divided by 1 plus 5 by 3. Okay. So here numerator you are having 5 by 3. Denominator after doing simplification you are getting 8 by 3. So here 3 is getting cancelled. You are getting 5 by 8 units are Henry. 5 by 8 Henry, that is there in option B. Yes, option B is the correct answer for this question. Okay, I hope it is clear for everyone. So in this way, regarding the network theory questions, whatever the given network is there or circuit is there, you should visualize. Once if you catch how the elements are connected, whether the elements are connected in series or parallel. Initially you may not guess, you may not get the clue whether the elements are connected in series or parallel. Suppose in some circuit or network like this, just put the labeling on regarding the nodes. Okay, regarding the nodes you can put the labeling. Once if you put the labeling, after that you are getting a clue. Okay, with respect to when you are analyzing any two nodes, you will come to know. Okay, with respect to the respective two nodes, whether the inductors or resistors or capacitors, what are the elements they have connected, whether the elements are connected in series or parallel, you will be coming to know. Once if you are able to get that idea, after that, initially you may thought this question is very tough, or in order to get the very correct answer, you might have put lot of effort or time taking and all. But here for understanding purpose, I have drawn equivalent circuit. But see, whatever the like simplification is there, that you can do in the mind level, and after that whichever steps are necessary, definitely you can write that steps, or even part of the circuit if required, then only you can draw. I am telling with respect to GATE exam. During the GATE exam time, because you are attempting the questions or you are writing the test in the online, right? So that is the reason, like suppose if physically this circuit is there, whatever here you are mapping or rounding off, like that you can easily do. But in the exam, if you draw the complete circuit and after that if you are putting labeling and all, definitely it will take time. That is not, I am not recommending like that, but the visualization you can do. Okay, visualization you can do, and after that whatever the necessary steps are required after doing the simplification, accordingly you can draw. Okay, in that manner if you do, definitely you can eliminate. In general, wherever majority of the students are doing the silly mistake, so those areas definitely you can overcome. Okay, even though solving or whatever the formulas here we have used while solving the questions, everyone is familiar, but only thing, most of the students are having, like calculation wise or connections wise, they are doing the misconception. That is the reason, even though these are silly questions or easy questions, but still many of the students are doing the silly mistake. That is the reason I want to highlight each and every model or variety of the question in this particular session, even in the tomorrow session as well, right? Okay, so all of you can mention, this is an excellent question. Yeah, next question. In this question, actually for the timing I have given this question as MCQ, but these kind of questions you can expect in the MSQ. Like here in this question, you have to find out the Vx value and you have to find out the Ix value. So regarding two choices you can have regarding Vx, and other two choices you can have regarding Ix. Okay. Any guess what could be the answer? This is a dead easy question only. See here in this question, we have to find out the Vx value and then we have to find out the Ix. First let us find out Vx. Here in this question, Vx is nothing but what? Voltage across 12 ohm. Voltage across 12 ohm. Okay. So if you carefully observe, here you are having 12 ohm resistor. Okay. So with respect to 12 ohm resistor, one side you are having 12 volt. Okay. Another terminal is having 2 volt. Another terminal is having 2 volt. That means voltage across this particular 12 ohm is nothing but the voltage difference of these two. That's all. Right. So here Vx is nothing but Vx is nothing but 12 minus 2. 12 minus 2, that is 10. Okay, 12 minus 2, that is 10, right? So regarding 10 volt, you are having two choices. Okay, since you are having 10 volt in two choices, other two choices we can eliminate. Okay, now among A and B we have to decide. Okay, right. So regarding other parameter, that is Ix, we have to calculate. So here Ix is present here. Okay, that Ix value we have to calculate. Now if you observe carefully, here you are having one dependent source. Yes or no? This dependent source, you are having voltage polarities plus minus. That means it is a voltage source, but it depends, in this question it depends on the current Ix. Okay, so that means it is a current dependent voltage source. Current dependent voltage source. Okay, right. Now if you closely observe, okay, say for example here I am labeling terminals 1 and 2, say for example. Otherwise you can consider A and B, no issue. Whatever the notation you want, your wish. Okay. So between the terminals A and B, you are having one voltage source. That voltage source value is 3Ix, correct? Okay, in this particular path. Okay, just for reference here I am mentioning, with respect to the terminals A and B, we are having one voltage source, that value is 3Ix. Okay, now see, this is one more path between the terminals A and B. Yes or no? This is one path A and B, and one more path is like this. Okay. Now here you are having already 2 volt plus minus 2 volt. Okay. Now here whatever this particular branch voltage you are having, for the timing I am keeping vertical element. Okay, vertical element, then voltage polarities you are getting minus plus. I hope it is clear for everyone. See, this 2 volt I have kept as it is. Now this plus minus 8 volt, whatever you are having, I am keeping like this. That means minus sign is coming top and then plus. Okay. Now just observe, whatever these two net together, you are getting that voltage that is existing with respect to terminals A and B. That means whenever you are having two branches which are respect to terminals are connected end to end, that means those two branches are connected parallel. In parallel, voltage will be same. Yes or no? Okay. Now just observe and tell me, here minus plus 8 volt, here plus minus 2 volt, whether we have to add or whether we have to subtract in order to get the respective voltage. In order to get the resultant voltage, whether we have to add or subtract. Yeah, just observe, here it is very simple. If both are having same polarities, that means here plus minus, here also plus minus, you can add. Or here minus plus, here also minus plus, you can add. But plus minus and minus plus, when you are having polarities opposite, that time you have to perform subtraction. Now here it is very simple, whether we have to consider minus or plus. Okay, your wish. Okay, say for example here, see, just observe here, here you are having 8 volt, here you are having 2 volt. Which one is smaller? 2 volt is smaller. That means smaller you can subtract from larger, like that. Okay. So that means, okay, yeah. So here 2 I am subtracting from 8, that means resultant voltage polarities you are getting the larger value polarity, that's all. Okay. So 8 minus 2, that is nothing but 6 volt. Okay. Now just observe. Now this is the most important. With respect to terminals A and B, one side you are having plus minus 3Ix. Okay. With respect to another side, you are having minus plus 6 volt. Okay, right. So since these polarities are not same, okay, that means this voltage you can write it as minus of this, or similarly vice versa, your wish. So from here I am writing minus 6 equal to 3Ix. So from here you are getting Ix equal to minus 2. Since here it is a current units are ampere. Ix equal to minus 2 ampere, that is there in option B, whereas here plus 2 ampere, so that means here this is not correct. Option A is not correct. So finally option B is going to be the correct answer. I hope it is clear for everyone. This question is very simple, but only thing many of the students may get confusion. Here you are having current value Ix, but here you are having source as voltage source. Okay, it is very simple. Whenever voltage polarities are given, that is a voltage source, that particular value overall it is giving output as voltage, that's all. Okay, similarly if you are having arrow symbol, that is a current source, like that, that's all. Okay, see whatever I have discussed here, this is a shortcut method, but it is very simple. Like if you apply KVL, okay, if you want, see this is one closed path, you can apply KVL around the closed path. Okay, from there whatever the final answer you are getting, here also same. But while writing the KVL, sometimes few students may do silly mistake. Okay, but that is the reason, in order to avoid, sir, whether we have to write minus or plus like that. So that is the reason, whenever you are getting like this pass, okay, just try to arrange in a vertical alignment like this, so that after that you can equate. Okay, even here one more approach I am telling, since here already plus minus is there, here also if you want to keep plus minus, that means here you can keep plus minus, that means 2 minus 8 you can write. In that manner, 2 minus 8 means what? Minus 6. So from there also directly you are getting. Okay, I hope it is clear. Right, next question. All of you give it try. In this question we have to calculate voltage across the terminals A and B. Between the terminals A and B, we have to find out the voltage. This is a simple question. I hope all of you can get the correct answer. All of you give it a try. Yeah, in this question you are supposed to find out the voltage across the terminals A and B, that is VAB. Right. Okay. Now just observe. Whenever you are having terminals A and B like this, that means here in this particular branch there is no current flows. Similarly here also there is no current flows. Okay. For the timing I have represented only here, but similarly you can represent here also. Okay. So here if there is no current flows, that means whatever the current to this particular node, here it is coming. See, in this case you are having current arrow symbol, that means it is what? Current source, and that current source value depends on some other current, that means it is a current dependent current source. Okay, right. Whatever the current here it is coming, the entire current will flow like this. Okay, the entire current will flow like this. So that means here 10ix. Okay, now whenever you are having resistor, in the resistor always current will flow from high potential to the low potential, or in other words you can say wherever current enters in the resistor, that particular terminal will be positive, and wherever current leaves, that is the negative terminal. That's all. Okay, so that means here VAB is nothing but voltage across this 3 kilo ohm resistor. Okay, just you can apply what? Ohm's law. Resistor multiply with current, that's all. So VAB is nothing but 3K into 10ix. 3K into 10ix. Okay, so here if you know Ix value, after that you are getting VAB, that's all. Okay, now how to get Ix? Very simple. You can observe here at this particular node. Okay, at this particular node if you observe, in these two branches currents are entering, here current is leaving. Okay, just apply KCL here. Just apply KCL. Here Ix is entering, so entering current negative. And similarly here 9 milliampere is entering, negative. Okay, whereas 10ix is leaving current is positive. I hope it is clear for everyone. You are applying KCL here, whichever branch current is leaving from the node, leaving current is positive, in whichever branches currents are entering currents are negative. Okay, right. So just do the simplification. 10 minus 1, that is 9 Ix equal to, this negative term you can bring to the right hand side, it will become positive. So you are getting 9 milli. So here 9 is getting cancelled. Ix you are getting, Ix you are getting 1 milliampere. See here, for understanding purpose I have written, but the same answer you can get without using pen and paper. Just closely observe. Here Ix is entering, 9 milliampere is entering, 10 Ix is leaving, right? Okay, first focus with respect to these two. First focus with respect to these two branches. Here Ix is entering, 10 Ix is leaving. That means 10 minus 1, 9 Ix is leaving. So that means here 9 milliampere is entering, net together 9 Ix is leaving. That means 9 Ix equal to 9 milli. So 9 is getting cancelled, Ix is nothing but 1 milliampere. That's all. Okay, in this way, wherever KCL you are supposed to apply, no need to write the equation, no need to write pen, no need to use pen and paper. In the exam I am telling, but here for practice you can write, no problem. Okay, so the moment you got Ix 1 milliampere, you can substitute here, that's all. So here 3 into 10, that is 30 K into Ix value is what? 1 milli. So kilo and milli both are getting cancelled, or other words, 10 power 3 into 10 power minus 3 is nothing but 1. So finally you are getting 30 volts. That is there in option B. Option B is the correct answer. I hope it is clear for everyone. If any of you are having any doubt, you can mention in the chart. Yeah, next question, all of you give a try. Yeah, whoever trying this question, still you can try, no issue, but I will be start giving the hint. Okay, so definitely what is the answer you are getting, you can mention the chart. Don't hesitate whether your answer is correct or wrong. Okay, if you are getting correct answer, I will appreciate you. If you are getting wrong answer, no issue, at least you are getting the opportunity that where you done the silly mistake or where you done the conceptual understanding lack, etc. Okay, and all these are learnings, all these are learnings. Definitely you can overcome all these silly mistakes wherever you are doing in this today's session and tomorrow's session regarding network theory subject. Definitely you can overcome, you can avoid these kind of silly mistakes in your coming GATE exam. Okay, right. So here in this particular question we have to find out the current IL that is flowing through the 20 ohm resistor. Okay, so when you observe this particular circuit diagram, I hope many of you might have got the thought that sir, we can apply nodal analysis. Yes, definitely, definitely you can solve this question by using nodal analysis. So just observe here, here in this case, okay, this in general we will be considering the bottom node as reference or ground. Okay, so here I am considering this node as a ground, right. After that, here you can observe in this branch, the current I is flowing according to this question. Okay, and here you are having one current source, that current source value depends on this current I. Okay, fine. And here in this particular 20 ohm resistor we have to find out the current. Okay, that current we don't know, but in this question they have labeled as IL, that IL value only we have to calculate in this question. Okay, right. Now here in this particular branch the current is entering, so entering current will be negative, and whereas here in this particular branch you are having two elements, both the elements connected in series. In series current will be same, right. So because of this current source, you know that 5 ampere is leaving from this particular node, right. Okay, here the current is leaving, whereas here current is entering, here also current is entering. Here according to this question, if you want the notation, here also you can consider current is entering. Okay, just apply one nodal equation here. So here 5 ampere is leaving, so leaving current is positive. Okay, whereas here in this particular branch the current I is entering, so entering current negative. Okay, similarly here 2I is entering, negative. Okay, similarly here IL is entering, okay, that is negative. So up to here if you observe, we have written like KCL only, that's all. Here at this particular node, okay, we have applied KCL, that's all. Here in this branch current is leaving, whereas in these three branches currents are entering. Okay, now here 5 as it is I am keeping, then minus I minus 2I, that is minus 3I, minus 3I. Now here in this case IL is nothing but the current flowing through 20 ohm resistor, but if you closely observe how these three elements are connected, 2 ohm resistor, 2I current source and 20 ohm, how these three elements are connected? Parallel, very good. Okay, in parallel voltage will be same, in parallel voltage will be same, because the current I is flowing like this, the voltage polarities you are getting plus minus like this, and 2 into I, that is nothing but 2I, so that is nothing but here the voltage across 2 ohm resistor is 2I, the voltage polarities you are having like this. Okay, so here also you will be having plus minus 2I, plus minus 2. Okay, now you can observe, here IL is nothing but by using Ohm's law you are getting 2I divided by 20, voltage divided by resistance. Here voltage value is 2I and resistance value is 20. So in this case 2 10 times, 2 10s are 20. Okay, fine. Now here you can do further simplification. I am bringing negative terms to the positive side, then you will be getting 3I plus I by 10 is equal to 5. Okay, 3I plus I by 10 equal to 5. You can do LCM and simplification. Here 10 is LCM, 10 3s are 30 plus I equal to 5. From here you are getting 31I equal to 50. From here you are getting I value as 50 divided by 31. 50 divided by 31. Here we cannot do simplification, you can keep like this only. See, whenever you are solving any question, just have the look at the choices. Okay, here in option D you are having 0 ampere. Other than that, remaining 3 choices you are having ratio of 2 numbers. Okay, whenever you are having NAT question or whenever you are having choices like fraction number or real number, that time only you can do the simplification. Otherwise, whenever if you are having choices like ratio of 2 numbers, then accordingly you can keep like that only. Okay, right. Here as of now we got I value as 50 by 31 ampere, but here in this question our objective is we have to calculate IL value. Here we have to calculate IL. Okay. Now if you closely observe regarding IL, already we have used the Ohm's law here, that is 2I divided by 20, that is nothing but I by 10, right. So here IL is nothing but I by 10. Here I value is 50 by 31 divided by 10. That means here 1 0 is getting cancelled, right. So that means you are getting 5 by 31 units, ampere. 5 by 31 ampere, that is there in option C. Option C is the correct answer for this question. Okay, I hope it is clear for everyone. Yeah, next question. All of you give a try. In this question, you have to find out the resistance value R. Here in this question, we have to find out the resistance value R. Okay, you are having a circuit diagram like this. Whichever method you are comfortable, you can do it. Nodal equation is nothing but what? KCL and Ohm's law. Okay, because in the previous question in 3 branches you know the currents, so accordingly we have represented. In 1 branch we don't know the current. In order to find out that current, we have used the Ohm's law. This is the question NAT type, so definitely answer will be a numerical, right. So here you have to do the simplification. When you are getting suppose ratio of 2 numbers, you can convert into normal number like real number. Right. So just observe here, first and foremost, these two resistors are contained in parallel, right. Find out the equivalent resistance. 8 into 12 divided by 8 plus 12. Okay, direct step I am writing. 8 into 12 divided by 20. Okay. So here 4 3s are 12, 4 5s are 20. So that means here if you do further simplification like 5 1.6 times, yes or no, 5 16s are 80. So here 5 into 1.6 is nothing but 8.0, that is nothing but 8 only. So 3 into 1.6, that is nothing but 4.8. In this way you can do the simplification easily. Okay, right. So as of now we got equivalent resistance as 4.8 among these two, okay, with respect to these two. Now after that if you observe this 4.8 resistor and this resistor R, both are contained in what? Series. Both are contained in series. Okay, right. In series we can add the resistors, right. So now if you closely observe, here you are having 15 ampere one current source and then 4 ohm resistor, and then here you are having net together you are having one resistor, right. So current source and then 2 resistors, all the 3 elements are contained in parallel. Okay, I hope all of you know that in parallel voltage will remain same, current will get divided. So here you can apply current division rule in order to find out the current flowing through this particular resistor. I hope all of you are getting the clue. Okay, right. So here by applying current division rule, by using current division rule, we can get the current flowing through any resistor. But here requirement is to find out this resistor value. Since we know the voltage, if you are able to find out the current flowing through this particular resistor, after that you can use Ohm's law. From there you can find the resistor. Okay, right. Now, if you want in this particular branch current, okay, or if you want in this particular branch current, irrespective of that, okay, the first and foremost, whatever the net current is entering, that current we will be considering. Now here this is the most important. If you want in this particular branch current, you have to consider opposite arm resistance. That means here 4 ohm. See, in this overall you want to find out the current, okay, other than that resistor, whatever remaining resistor, in this case only one resistor, but like this if you are having multiple resistors, you can find out the equivalent resistance. Okay, right. So here opposite is 4 divided by sum of the resistors. Okay, so here 4 plus, here just for reference I am mentioning this entire equivalent as R plus 4.8. R plus 4.8. Yeah, Akio, what is your name? Full name you can mention in the chart. Whatever the answer you have mentioned that is not correct, you can cross check. Okay. So for the timing you can mention your name in the chart so that I will pronounce accordingly. Okay, I will spell accordingly. So here IR we got like this. Now by using Ohm's law, here voltage across this resistor, okay, just for reference I am mentioning VR equal to the current flowing through it into resistor. Here in this question VR value they have given already 16 equal to, right, IR I am substituting here 15 into 4 divided by here 4 plus 4.8, that is 8.8 plus R. Okay, 4 plus 4.8 is 8.8 plus R. Okay, and then we are having R. Okay, I am repeating once again, voltage equal to current into resistor. Voltage value already they have given 16 volt, current value this one, right, into R. Now here you can do simplification. Here 4 times. Okay, now you can do cross multiplication. Right, when you do cross multiplication, here you are getting 4 into 8.8 plus R. 4 into 8.8 plus R is equal to 15R. Okay, here you can do further simplification. 4 8s are 32. 4 8s are 32 plus 3, that is 35.2 plus 4R is equal to 15R. Now you can bring this term to the right hand side, it will become negative. 15R minus 4R, that is 11R. 11R equal to 35.2. Okay, so you can do simplification. Here R value will be getting 3 11s are 33, then remainder is 2, that means 22 you are getting. So 11 2s are 22, but here radix point is there accordingly, right. So R value you are getting 3.2. Is it clear, Akio? For this question, answer is 3.2. If you are having any doubt or confusion, you can mention the chart. Yeah, I hope it is clear for everyone. Right, very good, very good. Yeah, next question. This is a very interesting question. Here in this question, we have to find out the current flowing through 28 ohm resistor. For the time being, just try to solve this question by using basic laws. Basic laws are what? KCL, KVL, Ohm's law, right? Those three are called as basic laws, because whatever the network or circuit you might be having, with the help of these basic laws you can solve, okay? But whatever the other methods you are having, like nodal analysis, mesh analysis, etc., those are the combination of these basic laws. Accordingly we got, okay? So for the time being, all of you give a try with the help of basic laws. Suppose if you are not comfortable with the help of basic laws, whatever the method you are comfortable for solving this question, all of you can give a try, no issue. I am not forcing you to solve only in this method. I am giving complete freedom for everyone. Whatever the methods or theorems that you have learned in the first and second chapter, with the help of whichever method you are comfortable, all of you can give a try. Your wish, completely choice I am giving for everyone. But after, okay, while discussing this particular question, first I am going to discuss with the help of this method, okay? I am giving time for everyone. All of you are having complete freedom. I am giving 2 minutes time. All of you give your 100% best, okay? Definitely you can get the correct answer. Whichever method you are comfortable, accordingly you can go ahead. Yeah, before solving this question, I am asking one simple question for everyone. For solving this particular question, from your first chapter and second chapter of network theory subject, whatever the concepts you have learned or whatever the methods you have learned, okay, can you guess in how many methods we can solve this particular question? Okay, whoever attending this session live, now you people can mention the chart. Whoever watching this particular session later, those students, you can mention the question number Q11 and mention for solving this particular question, what is the circuit diagram here you are having. For solving this particular question, in how many methods we can solve? Okay, this is a very, very interesting question. All of you just give a try, and whatever the number of methods you feel, sir, we can solve this question in so and so number of methods, just mention the number of methods. I am not expecting that name of methods, okay? Just think of, just try to recall what are the concepts you have learned in the first and second chapter, and by using those concepts, in how many methods we can solve this particular question. This is a very, very interesting question. Yes, very good, Ricky, very good. Okay, yeah, as of now you have mentioned 2 methods. Okay, whatever the methods possible for solving this particular question, I am going to cover each and every method in this particular session. Just you people can have the patience in this 1 hour. Okay, in the upcoming 1 hour, I am going to cover whatever the methods that are possible with respect to this particular circuit. Okay, so that you are getting the complete overview with respect to first chapter and second chapter, whatever the methods or theorems that you have learned. Okay, how to solve with respect to the given question. But actually with the help of this particular question or circuit diagram, you are getting the glimpse how to solve the given question in the respective method or theorem. Okay, but ultimately at the end of the last method, I will be given the conclusion points also, like for the given circuit. Okay, say for example for this circuit, which are the best methods. Okay, in the discussion I will be covering, and with the help of this one question, you are getting the clue or idea that whenever you are solving any network theory question, whatever the theorems or methods you have learned, with the help of which method or which theorem, you can easily solve the question in less time, because that is the most important in the GATE exam. If you are able to solve the network theory questions in the GATE exam in less time, definitely you can save the time for solving the questions related to your core subjects. Okay, right. So first, as I mentioned earlier, first of all, I am going to solve this question by using basic laws. But as of now, I am keeping suspense what are the total number of methods possible. But meanwhile, if you are getting any idea, you can mention the chart. Okay, right. So here, as I mentioned earlier, basic laws are nothing but KCL, KVL and Ohm's law, right? Those are the basic laws. Okay. Now just observe here. Here in this question, we have to find out the current flowing in this particular branch, 28 ohm. Okay, that current they have labeled as I, that we have to calculate, right? Okay. Now first and foremost, if you observe, say for example here I am considering this is the node. Okay, here to this particular node 3 branches are there. Okay, just apply KCL. Here I is entering, here 5 ampere is entering. So here in this particular branch, the current will leave. So the leaving current will be I minus 5. See how I have written without writing any KCL. It is very simple. Just observe when you are having 3 branches like this. Okay, say for example in this branch the current I is entering here, right? The same current should leave. That's all. Okay. Next, here in this branch 5 ampere is leaving. That means actually 5 ampere should enter. But since I have put the direction leaving, so leaving current should be negative. I hope all of you got the clarity. Or even if you are having slight confusion, no issue. Just apply KCL. Here in this branch current is entering, in these 2 branches currents are leaving. That means just add these 2, plus 5 minus 5 getting cancelled, resultant current you are getting I. Resultant current entering is I. Yes, it matched. Now similarly to this particular node, here in this branch 5 ampere is entering, here I minus 5 is entering. So once again if you apply KCL, 5 minus 5 both are getting cancelled, resultant current I is going like this. Okay, next in this branch already 10 ampere is going like this. Okay, already 10 ampere is going like this. Now once again if you apply KCL here in this particular branch, the resultant current flowing is I minus 10. I minus 10. Just observe. See here current is entering, whereas here currents are leaving. Plus 10 minus 10 both are getting cancelled. I is leaving, I is entering. That's all. Okay. And even if you complete here, whether what is the analysis we have done, whether it is correct or not, even if you are having slight confusion, just apply here. Here I minus 10 is entering, here 10 is entering, both are entering, 10 minus 10 both are getting cancelled. Net current I entering, net current I is leaving. Yes, exactly satisfying. Okay, right. So first what I have done, I have applied the KCL here at this node and at this node, Okay, one law I have used KCL. Now once if you know the current flowing through any resistor, accordingly you can put the voltage polarities plus minus, and by using Ohm's law you can get the voltage across it. That's all. Okay, now I am using what? Ohm's law. Okay, in order to find out the corresponding voltage across the branch. Okay, next similarly here the current I minus 10 is entering like this. So accordingly here the voltage across 4 ohm you will be getting plus minus 4 into I minus 10. Okay, similarly here in this particular branch the current I is entering, you can apply Ohm's law, you will be getting voltage polarities like this. Okay, so I have used KCL and then I have used KVL, right? Okay, now in order to find out, see I have used KCL as of now and then I have used Ohm's law in order to find out the respective voltage. Okay, now you can apply KVL, 3 laws. Okay, right. So see KVL we can apply where? whenever you're having any closed path. That's all, right? So here just observe, this is the closed path. This is a closed path. Yes or no? Here you are getting voltage. Here these two are contained parallel. In parallel, voltage will be same. And here you are having voltage. That's all. Just apply KVL. So first I am starting from here. Plus 2 minus. Okay, I will write here. Plus 2 minus 28 into I. Okay, next here plus 2 minus 8 into I minus 5. 8 into I minus 5. See, whenever you are writing KVL, with respect to every element, you can consider the starting polarity or second polarity throughout the equation. Okay, right. For the time being, I am considering second polarity. Plus 2 minus, here plus 2 minus. Okay. Similarly, here plus 2 minus 4 into I minus 10 is equal to 0. So in any closed path, sum of the algebraic sum of voltage drops around any closed path is equal to 0. That is nothing but KVL. Okay. So here I have put the heading, by using basic laws we are solving the question. We have used the KCL, we have used the Ohm's law, we are using KVL, right? Okay. I hope all of you got the clarity how to apply even with the help of basic laws, how we can solve the question. Okay, right. Now in this entire equation, you can take minus 4 as common. You can take minus 4 as common. Then what you will be getting? Here 7 times I. Okay. Since from every term you are taking minus 4 as common, so all the terms will become positive. Okay, right. 7 4s are 28. Then here 2 into I minus 5. Then plus I minus 10. Okay, is equal to 0. So 0 by minus 4, definitely it will be 0. Okay, then 7i plus 2i, that is 9i, 9i plus I, that is 10i. Next, minus 2 into 5, that is minus 10, then minus 10 is equal to 0. So 10i is equal to 20. From here you are getting I value as 2 ampere. Answer for this question is simple, 2 ampere. The current flowing through 28 ohm resistor is 2 ampere. Okay, this is the first method. Okay, right. Now let us solve the same question by using nodal analysis. Same question, same circuit. Okay, now we are going to solve by using nodal analysis. Okay, right. So when you want to solve any circuit or network by using nodal analysis, first of all you have to identify the principal nodes. So all of you just tell me, for this circuit, how many principal nodes we are having? Any guess? How many principal nodes we are having? All of you can mention the chart. For this circuit, how many principal nodes we are having? Yeah, just observe, this is one principal node. Sorry. Yeah, this is one principal node, this is second principal node, and this is the third principal node. Okay, only 3 principal nodes, yes or no? Because this point, all are same. See, principal node means it is very simple. To whichever point or node, if at least 3 branches are connected, that is a principal node. 1, 2, 3 here, 1, 2, 3 here, right? And whereas here 1, 2, 3, 4, because here bottom all the points are same only, correct? Okay, if at least 3 branches, that means minimum 3 branches should be connected, more than that any number. Okay, to whichever point or to whichever node they connected, that particular point or node we are calling as principal node. Okay, So here we are having 3 principal nodes, among which one node we will be considering as reference ground. Okay. Now this node voltage with respect to ground you can label as V1. Similarly, this node voltage with respect to ground you can label as V2. So here, since you know this one we have assumed as ground, so that means 2 unknown voltages are there. That means that many nodal equations are required, because if you write 2 nodal equations, then you are getting 2 equations in terms of 2 unknowns. 2 equations, 2 unknowns we can solve. Okay, right. Now, while you are solving the question by using nodal analysis, in whichever branch current direction and current value you know, accordingly you can consider. In whichever branch you don't know the current value, okay, in that branch you can assume that from that node you can assume that currents are leaving. Similarly, if you want, you can assume currents are entering, no problem at all. But while solving that particular question, throughout the question you can consider the same assumption. Okay, right. So here 10 ampere is entering current will be negative minus 10. Okay, in this branch you can assume that current is leaving. Okay, leaving current is positive, V1 by 4. Similarly, in this branch you can assume that current is leaving current is positive. So here V1 minus V2 divided by 28. V1 minus V2 divided by 28 is equal to 0. Sum of all the leaving currents from a particular node is equal to 0. Okay, now you can take the LCM. 4, 28, LCM obviously 28. Okay, next here minus 280 plus 4 sevens. Next here 28 one time, so you can write V1 minus V2 is equal to 0. Now you can do cross multiplication, 0 into 28, 0 only. Okay, so from here you are getting 7 plus 1, that is 8 V1 minus V2. Okay, I am writing the direct step. So this minus 280 we can bring to the right hand side, it will become positive. So this one you can label as equation number 1. I hope all of you got the clarity. 7 plus 1, that is 8 minus V2, 280, negative term I brought to the right hand side, it will become positive. Okay. Right. Now let us write the nodal equation here. Nodal equation here. So here in this branch you can assume that current is leaving from this node. Leaving current is positive, V2 by 8. V2 by 8. Okay. Next here already current is leaving 5 ampere. Leaving current is positive plus 5. And now in this particular branch you can assume that current is leaving from this particular node. See, at whichever principal node you are writing the nodal equation, whichever branch connected to that particular node, if you don't know the current value in that branch, you can assume that from that node the current is leaving. Okay, from that node the current is leaving in that branch, like that, simple. Okay. Now here leaving current is positive, so here plus V2 minus V1 divided by 28 is equal to 0. Okay. In this case you are having 4 and 28, LCM you got 28. Now here 8 and 28, what is the LCM? All of you can mention the chart. For 8 and 28, you will be getting 56, yes or no? So here 8 7 times into V2 plus 5 6 are 30, then 5 5 are 25 plus 3, 28, 280, then 28 2 times. So here I am writing one step like this, 2 into V2 minus V1 is equal to 0. Yes, very good Medha, very good. So here you can do the cross multiplication. 0 into 56 is 0. Then minus 2 V1, I am keeping in the normal order, V1, V2 and then constant. Okay, minus 2 V1, then 2 V1 plus 7 V1, that is 2 V2 plus 7 V2, 2 plus 7, 9 V2. I am repeating once again, minus 2 V1, then 2 plus 7 is 9 V2. Okay, 280 I am bringing to the right hand side, it will become negative. This one is equation number 2. Now closely observe equation 1 and 2. What is your observation? Here 8V1 minus V2 is equal to 280. Here minus 2V1 plus 9V2 equal to minus 280. If you observe the first term, here 8V1 is there, here minus 2V1 is there. Just multiply whole equation with 4. Just to do the simplification easy without using calculator, right? I am telling, I hope all of you know this procedure, okay, right? Just by observation here first term, okay, I am multiplying whole equation with 4. So accordingly you are getting 4 2s are 8, then 4 9s are 36, then here no need to simplify, keep as it is. You write like this, minus 4 into 280. No need to simplify in this question. The reason is, here you are already having what? 280. Here you are getting minus 4 into 280, you keep as it is. Now this one I am labeling as equation number 3. Equation number 3. Now equation 1 and equation 3, if you add, okay, from there you can find out V2. After that V2 you can substitute either 1 or 2 or 3. Any one equation you can substitute. From there you can find out other unknown. After that you can use Ohm's law. From there you can find out I value. Okay, right. So for the timing I am considering 1 and 3 I am adding. 1 and 3 I am adding. So here 8V1 minus 8V1, both are getting cancelled. Minus V2 plus 36 V2, that means 35 V2 is equal to. Now here 280 plus of minus 4 into 280, that means you are getting minus 3 into 280. I am repeating once again, here 1 time 280, here minus 4 time 280. 280 when you took common, 1 minus 4 is minus 3. Okay, right. Now here you can do simplification. Right. So here 7 5s are 35, 7 40s are 280, and then 5 8 times. So from here you are getting V2 equal to minus 24. V2 equal to minus 24 volts. Okay. Now you can substitute V2 either in equation 1, equation 2 or equation 3. Choice is yours. And from there you can find out the V1. Suppose I am substituting V2 here in the first equation. 8V1 minus V2. V2 we got minus 24 is equal to 280. So here you can write 8V1. So in the whole equation you can divide with 8. 8 1s, 8 3s. Here 8 3s are 24, remainder is 4 and then 0. 8 5s are 40. So from here you are getting V1 equal to 35 minus 3, that is 32. Okay. So V1 we got and then V2 we got. Now you can use Ohm's law, that's all. In order to find out the current, I equal to V1 minus V2 divided by 28. So here V1 is 32 minus V2, we got minus 24 divided by 28. So here minus of minus plus, okay, 32 plus 24. 36 plus 20, that is 56 divided by 28, that is 2 ampere. See, here calculation you can avoid if you are using calci. Okay, but here why I discuss this calculation also, because some questions you can without using calci, the calculation part will be easy only, but only thing if you are practiced or if you are habituated, wherever without using pen and without using calci, whatever the calculation part you are comfortable, better do it so that you are becoming comfortable. Okay, at least for some questions here, because you are getting numbers very big, that is the reason we have done more steps. But if we are getting like simple numbers and all, then even for solving these two equations you can do simplification the mind level. Okay, right. So whatever the answer earlier we got 2 ampere, the same answer we got. Okay, the same answer we got 2 ampere, right. Now the next method, mesh analysis. Now before solving by using mesh analysis, all of you confirm in the chart whether is it possible to solve this question by using mesh analysis or not. All of you confirm. All of you confirm in the chart for solving this question whether in the mesh analysis whether we can solve or not. All of you can just observe the circuit and you can confirm. Only by using mesh analysis is it possible or not? That is my question. If you want more clear about my question, whether only by using mesh analysis whether we can solve this question or not. Yeah, here the most important thing. First and foremost, tell me in this circuit how many meshes we are having. In this circuit how many meshes we are having. This is one mesh, this is second mesh, this is third mesh, right? Okay, 3 meshes are there. So here in this case, with respect to first mesh, if you consider mesh current in the same as this branch current, so that means without writing the mesh equation I1 you can say 10 ampere. There is no problem here. Yes. With respect to this first mesh, okay, you are directly getting I1 equal 10 ampere. Now, if you want to write mesh equation here or here, now you can write, but how many unknowns you are getting? How many unknowns you are getting? See, here I2 is one unknown, I3 is one unknown. Okay, but here across 5 ampere, do we know the voltage? We don't know. That means you are getting what? 2 equations but 3 unknowns. Whether is it possible to solve any set of question like this, 2 equations are there, 3 unknowns are there. Is it possible to solve? No. So that is the reason I have asked the question clearly. Is it possible to solve this question exclusively by using mesh analysis? No. Because see here for first mesh there is no problem, but for second mesh and third mesh, for these 2 meshes, you are having current source which is common for both the meshes. Whenever current source is common for both the meshes, and if we don't know the voltage across it, then we have to use the concept of super mesh. Okay, so here you can mention the heading. We have to solve this question by using mesh analysis and by using super mesh concept. Okay, I hope it is clear for everyone, right? Now let us solve this question by using mesh analysis and super mesh. Okay, so here first of all, yeah, so you can consider with respect to first mesh, I am considering the mesh current I1 like this. Okay, similarly second mesh, I am considering I2 like this. Third mesh, I3 like this. For the timing I have considered clockwise. If you want, you can consider anti-clockwise, or in one mesh clockwise, other mesh anti-clockwise, completely choice yours. But here with respect to first mesh, why I considered clockwise? Because here in this case, current direction is upward. Okay, so whenever one branch current and mesh current, definitely whenever you are having a branch, and then with respect to branch you are having current, that is a branch current. With respect to mesh you are having the current. So branch current and mesh current both will be same. That is the reason whichever direction you are having, accordingly you can consider mesh current. Okay, right. So here you are getting as of now I1 value is 10 ampere. Okay, right. Now here whatever the logic currently I told, the same logic you can apply here. You are having 28 ohm resistor. In that particular 28 ohm resistor, the current flowing is I. The current flowing is I, and that current and here mesh current both are in the same direction. So once again same logic. So here I equal to I2. Okay, mesh current, branch current, mesh current, both are same. Okay, fine. Next, here just observe. So when you are using super mesh, it is very simple. Whatever the current source, because of the current source we are unable to, right? So just remove the current source from the circuit, then superficially we are getting one closed path, that is called super mesh, that's all. Okay, but before yeah, just remove this one. Now with respect to this current, voltage polarity is like this, plus minus. Similarly here in this branch only I3 current is flowing. According to that, voltage polarity is like this, plus minus. And now here you are having 4 ohm resistor. With respect to this mesh, second mesh, I2 current is flowing upward. With respect to first mesh, the current 10 ampere is going downward. That means in the upward, the resultant current, since current directions are opposite, we have to subtract. So that means we can write I2 is nothing but what? I minus here 10. And current is flowing like this, voltage polarity is plus minus. Okay, so just you have to apply here one KVL. Okay, in this closed path you can apply KVL, that's all. Okay, after removing the common current source. So here plus 2 minus 20 minus 28I, then plus 2 minus 8 into I3, then once again plus 2 minus 4 into I minus 10 is equal to 0. Okay, so from the whole equation you can take minus 4 common. Minus 4 if you take common, then you are getting 7I. Dash step I am writing because we already solved similar kind of thing earlier. Okay, minus 4 I am taking common, whole equation. After that minus 4 you can divide on the right hand side. 0 by minus 4 is 0. Okay, so 7I, then plus 2I3, then plus minus 4 I took common, right? So here I am getting I minus 10 is equal to 0. Okay, now here you are getting 7 plus 1, that is 8I plus 2I3 is equal to 10. Okay, this much here we got. Now what we are doing? Here you are having I and I3. Two unknowns, one equation, not possible. Now ultimately our objective is I, so let us try to get I3 value in terms of I. So simple. Now earlier what we have done, we have removed the current source from the circuit, then we have applied the KVL. But actually in the circuit the current source is there. Now either at this particular node or at this particular node, choice is yours. You can apply anywhere KCL, that's all. If you apply KCL, now what will happen? Here I is entering, whereas 5 ampere and I3 both are leaving. Okay, here I is entering, 5 ampere and I3 both are leaving. So that means from here I am writing I equal to 5 plus I3. Simple. Super mesh means what? After removing the current source, we have applied KVL. There we have used Ohm's law, and then we have used two laws, KVL and Ohm's law, right? Okay. Now the leftover law is what? KCL. That we have to apply after considering the current source. That's all. Okay, fine. So I equal to 5 plus I3. From here, just here in this equation, I3 equal to I minus 5. I3 equal to I minus 5. So this one you can substitute here. Okay. Now from here you are getting 8I plus 2 times I minus 5 is equal to 10, right? So 8I plus 2I, that is 10I, minus 2 5s are 10 is equal to 10. You can bring minus 10 to the right hand side, it will become positive. So from here you are getting 10I equal to 20. So you are getting I value as 2 ampere. Okay, I hope it is clear for everyone. Generally, few students will face the difficulty how to apply the super mesh. Okay, it is very simple. Because of the current source, we are unable to solve the question completely because you are getting 2 equations, 3 unknowns. That time, just remove the current source, then superficially you are getting one closed path, that is the super mesh. Okay, just write the super mesh. Inside the super mesh, you write the KVL, okay, or mesh equation. Okay, after that, you consider the current source and then apply KCL. That's all. Is it clear for everyone regarding this method? Yeah, now the next method, yeah, as Medha has mentioned, sir, we can solve this question by using source transformation. Yes, we can solve this question by using source transformation. Now we are going to solve by using that one. Okay. So just for practice, earlier we have discussed by using basic laws and then nodal equation or nodal analysis and then mesh analysis, and along with the mesh analysis, we have used the super mesh as well. Okay. Now we are going to solve this question by using next method, by using source transformation technique. Here the most important thing, while you are applying source transformation, you should aware that, like here in this particular circuit, when you have observed here in the 28 ohm resistor, you have to find out the current. Okay, that is your response. Here response means it can be current or it can be voltage. Okay, right. Now you should not disturb that particular position of that particular branch where you are supposed to find out the response. Okay. Without disturbing that, wherever there is a possibility to apply source transformation, you can apply, and provided if you can get the you can do the simplification easily. What I mean to say, even though source transformation is applicable in some cases, but unnecessarily no need to apply. But because of the source transformation, if the circuit is becoming even more simpler, or if the number of equations required for solving the question is going to less, then definitely you can apply source transformation, and provided the first and foremost, whatever the point I have addressed, that is the most important. Wherever you are supposed to find out the response, that particular branch position should not disturbed. That's all. Okay. Now if you observe, all of you tell me in this particular circuit, like whether, like in which places we can apply source transformation, whether only one place, left hand side, or only right hand side, or even both. All of you can confirm in the chart. For this particular circuit, whether one source transformation possible, or two, or one is at left only, or one is at right only, or even both. All of you can mention in the chart. Yes, we can apply at both left hand side and right hand side. Okay, just observe here. You are having what? Current source in parallel with resistor. Okay, so here we can apply source transformation. Okay, similarly here, current source in parallel with resistor. Here also we can apply source transformation. By applying source transformation, what will happen? You are having practical current source that you are converting into practical voltage source. Similarly here also. Okay. Now, here regarding in the practical voltage source, you are having what? A voltage source in series with resistor, right? That voltage source value is nothing but just you can apply, like whatever the current source value and resistor is there, just multiply, that's all. Here 10 into 4, that is nothing but 40. So here voltage polarities you will be having like this, plus minus 40. See how to represent the voltage polarities. Some students might be having the doubt. It is very simple. When you are having current source like this, current source arrow symbol like this, that means since we are telling it is a source, definitely it has to leave from where? Positive terminal, like that, that's all. Okay. After that, internal resistance value, same resistance we are keeping, that is 4 ohm. Okay, right. Then here 28 ohm as it is you can keep. Okay, next, here also you can apply source transmission. So here I am keeping first resistor 8 ohm, then voltage source value will be 5 8s are 40. Now here the most important thing, voltage polarities, whether I have to keep like this or volta. All of you confirm whether I have to represent voltage polarities plus minus or minus plus regarding this one. See, just observe here current source arrow symbol is downward, that means current has to leave from the positive terminal when you are saying source, right? So that means here minus plus you are getting. See, when you consider voltage polarity is minus plus, current is leaving from positive terminal in the same direction you are having, correct? 5 into 8, that is 40 volt. See the beauty of this circuit. The moment you have applied source transformation here left hand side and right hand side, now you are getting what? One closed circuit, that's all. So in this manner, for whichever question you want to solve by using nodal analysis, okay, so just cross check with the help of source transformation whether we can solve the question in less time or whether we can reduce the number of equations going to solve is going to be less or is going to be minimized or not. Just cross check. If it is possible, definitely you can apply, okay. So if you apply source transformation technique without using pen and paper, here for understanding purpose we have drawn like this, okay, represented everything, but you can do whatever the calculation, okay, in order to find out the corresponding current I, you can easily get without using pen and paper. That much dead easy question this is. But the same question when we have solved by using nodal analysis, we took lot of time in order to solve two simple equations, okay, right. Now with the help of source transformation technique, we are getting one simplified circuit or one closed circuit, that's all, okay. So now just observe all the elements are contained in series, okay. Some of you might thought that, sir, we have to apply KVL. Of course you can apply KVL, you can get the same answer, but I am telling in the easiest manner, okay. Now just observe in this overall circuit, here 4 ohm, 28 ohm and 8 ohm all are contained in series. We can add the resistors. So 28 plus 8, 36 plus 4, that is 40 ohm. So you are getting 40 ohm resistor and the current is flowing like this, okay, right. Now whatever the two voltages here we are having, whatever in one of the earlier question I have mentioned the voltage polarities, like that method I am doing now, okay. So first of all I am keeping voltage polarities plus minus 40 here, right. This voltage source polarity I have kept as it is. Now what I am doing, this voltage source polarity I am keeping vertical element. When you are keeping vertical element, then here you are getting plus minus. See, it is very simple. Here minus is there and then plus, after that minus, that's all. Now just observe, here voltage polarities are same. Now we can add, so 40 plus 40, that is 80 volt. Now this entire 80 volt, where you are having, just observe, whatever I have told, here this is the positive terminal, this is the negative terminal. You can observe closely. Yes or no? When you consider this entire path, that means across 40 ohm, you are getting 80 volt, that's all. Now you can use Ohm's law. Here you are having 40 ohm resistor, the current is flowing like this, okay, right. So here I equal to 80 divided by 40, that is 2 ampere. So this is the best method, excellent method. For this question, if you solve by using source transformation technique, you can easily get the answer in less time. How many of you feel this is the best method? You people can mention the chart, and whoever watching this particular session later, those students can mention like the question number 14. If you feel, sir, this is the best method, you can mention question number 14 and best method. Okay. So in general, best method means what? The word best when we are using definitely applicable for one. But for this question, you may be getting more than one also. Okay. Can you guess what is the next method? In which method we are going to solve the same question? Any guess? All of you can mention the chart. Yes, we are going to solve by using superposition theorem. See, whenever you are having multiple sources present in the given circuit, if you want to find out the response in a particular branch, you can consider one source at a time. Okay. Now we are going to solve by using by using superposition theorem. Now, here in case 1, I am considering this current source. That means the other current source we have to deactivate. So deactivate means the current source value is 0 ampere. So 0 ampere means open circuit. Okay, 0 ampere means open circuit. This is a case 1. Okay. Similarly, case 2, we have to consider 5 ampere source, other current source we have to deactivate. Here in this case, since current source we are deactivating, it is a 0 ampere open circuit. Suppose if voltage source is there, we have to make it short. Okay, right. So see, this question if you are solving with the help of superposition theorem, you can solve this question without using pen and paper, because the moment you are eliminating one source, you are getting the simplified circuit. Now here, which law we have to apply or which rule we have to apply? All of you mention the chart. Here you are having current source and then 4 ohm, and here there is no current flows. That means these two resistors, how they are connected? Series, that's all. Right. In this branch, if no current flows, these two are connected in series, that's all. 28 plus 8, that is 36 ohm. 36 ohm. Right. Now just observe 10 ampere, 4 ohm and 36 ohm. All are connected in parallel. You can apply current division rule. That's all. That's all. Here in case 1, I am assuming that the current I1, okay, I1 equal to supply current is 10 ampere, opposite arm resistance that is 4 divided by sum of the resistances. Okay, 4 plus 36. Right. So here you are getting 10 into 4 divided by 40. So that means you are getting 1 ampere. 1 ampere. Right. Similarly here, in case 2, I am labeling this current as I2. I2. Now, in this branch, since there is no current flows, here 28 ohm and 4 ohm, both are connected in series. So we can add, that is 32 ohm. Now once again, just like this circuit, here you are getting 5 ampere, 8 ohm and 32 ohm. All are connected in parallel. Right. Here 5 ampere is coming to this particular node, 5 ampere is coming. Right. In this particular branch, we have to find out the current. Okay. Since in this branch there is no current flows, the same current is flowing like this. Okay. So just for reference, here I am mentioning 0 ampere. Here it is I2. The same current I2 is flowing like this. Okay. We can apply once again current division rule. I2 equal to entering current is 5, opposite arm resistance is 8, divided by sum of the resistors. Okay, 32 plus 8. 5 8s are 40, divided by 40. Once again you are getting 1 ampere. Right. In case 1 we got 1 ampere, case 2 we got 1 ampere. Current directions is same. Right. Now by using superposition theorem, you can, since the current directions are same, you can add the respective currents. That's all. Okay. By using superposition theorem, In short, I am writing SPT. The resultant current I equal to I1 plus I2, that is 1 plus 1, 2 ampere. Suppose if the current directions are opposite, then we can perform subtraction. Okay. In this case, current directions are same. That is the reason whatever the values we got, we can add. Same answer, 2 ampere. See, earlier we have mentioned by using source transformation technique, we can solve the question easily, even with the help of superposition theorem. For this question, we can get the answer easily. Here, for understanding purpose, we have written these steps, but this calculation you can do in the mind level. Okay. This is also best method. Whoever feel, sir, this is the best method, just like earlier source transformation, this is also best method, you people can mention in the comment section or chat section. Generally, best method means only one. But for this question, source transformation is also best method, and even superposition theorem is also best method for this question. Okay, right. So, up to now we have discussed with respect to some concepts related to the first chapter and even second chapter with the help of superposition theorem. Okay. With this, now let us try to solve the same circuit or same question with the help of other theorems of second chapter. The first one, that is, as of now we already covered superposition theorem. The next theorem is Thevenin's theorem. All of you just think how to apply Thevenin's theorem here. Yeah, when you have studied the Thevenin's theorem, okay, so you might have observed one important, like while you have written the statement or before discussing any theorem, you might have studied one important point. See here, in this circuit, we have to find out the current flowing through 28 ohm resistor. That means this is what? You can consider this 28 ohm resistor like load resistor, right? So just remove this particular resistor. This is the load. Okay, you can connect this load at the last. Okay, now the moment when you remove the load resistor, then terminals become what? Open. So across the open circuit terminals, you can find out the Thevenin's equivalent circuit. Similarly, we will solve the same question in the next method, that is the Norton's theorem as well. Okay. After that, what is Thevenin's equivalent circuit you are getting? For that circuit, you can connect this load resistor and then you can find out the current value. Okay, right. So here, first of all, as I mentioned earlier, this 28 ohm resistor you can remove from the circuit, then terminals will become open. With respect to the terminals, we have to find out the Thevenin's equivalent circuit. Okay, first of all, let us find out the Thevenin's voltage here, VTH, and similarly, we'll calculate the Thevenin's equivalent resistance here. Okay, regarding this one, we'll discuss in some time. Okay, right. So here VTH we have to find out. Okay, so it is very simple. The moment you have removed the resistor, that means here terminals become open, there is no current flows in this branch, right? Now, the moment you observe that in this branch there is no current flows, okay, whatever the 10 ampere current enters, the same current is flowing like this one closed path. Yes or no? Here 10 ampere is flowing. Here 10 ampere is flowing. By using Ohm's law, you are getting 10 into 4, that is 40 volts. 10 into 4, that is 40 volts, right? Okay. Next, here path is open. That means whatever 5 ampere is coming, that's entire 5 ampere is going like this. This is one closed path. Yes or no? Here 5 ampere is coming like this. Now, once again by using Ohm's law, you are getting voltage polarities like this, plus minus 5 into 8, that is 40 volts. 40 volt. Okay. Now just observe, very simple. Here, see, you just observe here. Here VTH we have to calculate. That VTH is nothing but what? This node voltage minus this node voltage, correct? This node voltage is nothing but this one, this node voltage is nothing but this one. Like that you can do, or otherwise Okay, you can apply whatever the voltage polarities I have represented accordingly. Okay, just for reference, here I am labeling this node like, say for example, V1, and this node is like V2. Okay, just for reference. Okay, so here VTH is nothing but V1 minus V2. So V1 just now we got 40 volt minus V2, here we are getting minus 40 because polarities you are having minus plus, right? So minus of minus, that is plus. So 40 plus 40, that is 80 volts. VTH we are getting 80 volt. Now we have to find out across the open circuit terminals RTH. So in order to find out RTH, so in the given circuit you are having what? Independent current sources. Independent current sources you have to replace with their internal resistance. Okay, so that means here internal resistance of current source is what? Infinite, that means open circuit. Here also it is open circuit. Suppose if you are having independent voltage sources, we will replace with its internal resistance. That means the value is 0 ohm. Ideal case I am talking. Okay, so 0 ohm means what? Short circuit. Okay, so here open, here also open. Now with respect to these two terminals, we have to find out RTH. Now tell me how 4 ohm and 8 ohm are connected. How these two resistors are connected. Here there is no current flows, here there is no current flows. That means you can remove these two branches. Now 4 ohm, 8 ohm. With respect to these two terminals, 4 ohm, 8 ohm connected in series. That's all. Yes sir. So RTH equal to 4 plus 8, that is 12 ohm. 4 plus 8, 12 ohm. Right? Okay. So we got VTH, we got RTH. Now you can draw the equivalent circuit. VTH in series with RTH. VTH value is 80 volt. We have to keep in series with internal resistance RTH. RTH is 12 ohm. Okay. Now here we can connect the load resistor. Here load resistor is what? 28 ohm. 28 ohm. See, after you have removed 28 ohm, whatever the simplified circuit we got, that is your 80 volt and then in series with 12 ohm. That is the Thevenin sequence circuit. Now you can keep this load resistor, that is 28 ohm. So here in this particular branch, we have to find out the current. Okay. So here 12 ohm and 28, both are connected in series. So 12 plus 28, that means 40 ohm. Yes or no? 40 ohm. So just you can use ohms, so that's all. So here I equal to 80 divided by 40, that is 2 ampere. Same answer. Okay. So in whichever branch you want to find out the response, that branch you can remove from the circuit, then terminals become open. Across those open circuit terminals, you can find out the Thevenin's voltage, you can find the Thevenin's resistance. Okay. In order to find out Thevenin's voltage, it is very simple. Here you got the voltage, here you got the voltage, after that you are applying KVL. Or otherwise, difference of those two node voltages. That's all. In order to find out RTH, see here for finding VTH or RTH, whether we require pen and paper? Not at all. Like that, you can just think of with whichever method or whichever theorem without using pen and paper, or with the help of simple calculation or less calculation, with the help of whichever method and theorem, if it is possible, accordingly you can apply the respective method or theorem. Okay, I hope all of you like this particular method also. So this is also best method I am putting. Generally best means for one only applicable, but here for this question you are getting best methods 3. Okay, but you can decide among these 3, whichever is comfortable for you, accordingly you can go ahead. Generally best means 1, but for this question you are getting 3 best methods. Okay, right. Yeah. Now the next one, by using Norton's theorem, all of you give a try. I am giving some time. All of you give a try. Yeah, aptitude class also will start. Okay, will start soon. Whoever want to attend that class, okay, when the session is going to start, accordingly you can join. Okay, all of you give a try this question by using Norton's theorem. Yeah, whether any students tried this question by using Norton's method, and whoever tried, you people can mention the chart. Yeah, it is very simple. So in order to find out the Norton's equivalent circuit, whichever load resistor is there, first you are removing the load resistor. After that, you have to find out the Norton's equivalent circuit with respect to the, after removing the load resistor, what are the terminals you are having with respect to that. Okay. So that means in order to find out the Norton's current or short circuit current, both are same. Here we have to short the terminals. Here we have to short the terminals. See, in order to find out the voltage, we have to open the terminals. In order to find the current, we have to short the terminals. Okay. So here the short circuited terminals current, that is ISC or Norton's current, both are same. Okay, right. Now here we have to find out that current. Now just observe here. Here 5 ampere is leaving, so that means in this particular branch, ISC minus 5 is leaving. If you apply KCL here, minus 5 plus 5, both are getting cancelled. ISC is entering, ISC leaving, correct? Okay. Next, here if you apply KCL, once again, here resultant current ISC is going. Next, once again you can apply KCL here. Here 10 ampere is leaving. Here ISC is entering, so that means the resultant current is ISC minus 10. You can apply KCL here, plus 10 minus 10, both are getting cancelled. ISC is entering, ISC leaving, that's all. Okay. Now after that just apply Ohm's law here, you are getting voltage. Similarly here you can apply Ohm's law, you are getting a voltage. Now this voltage should match, yes or no? Because here 4 ohm resistor, 10 ampere, 5 ampere, 8 ohm, all are contained in parallel. In parallel voltage will be same, that's all. Okay. So just here I am applying Ohm's law. Here you are having polarities minus plus. Okay. Then 4 into ISC minus 10. 4 into ISC minus 10. Okay, right. Next here voltage polarities you are getting plus, minus, and then 8 into ISC minus 5. 8 into ISC minus 5. So since these two branches are same, definitely voltage should match, but here voltage polarities are not same, right? Voltage polarities are not same. That means here this voltage you can write it as minus of this voltage, right? That is the most important. So from here I am writing like this, minus 4 into ISC minus 10 is equal to 8 into ISC minus 5. Okay. So here 4 2 times. Okay. So you can do the simplification. Here you will be getting minus ISC plus 10 is equal to minus ISC plus 10 is equal to 2 ISC minus 10. 2 ISC minus 10. Okay, right. So you can bring this one here, it will become positive, and this term you can bring here, it will become positive. Okay, 2 plus 1, that is 3. 3 times ISC is equal to 10 plus 10, that is 20. So from here you are getting ISC, that is nothing but Norton's current, that is 20 by 3 ampere. 20 by 3 ampere. Okay. Regarding Norton's resistance and Thevenin's resistance, both are same only. Okay. So what are the current source here we got, that value we can keep here, 20 by 3 ampere current source. We have to keep in parallel with Norton's resistance. So Norton's resistance is, earlier we got RTH how much? RTH we got 12 ohm, same. RN also same, 12 ohm. Now after this you can connect the load resistor, that is 28 ohm. And in this case we have to find out the current flowing in this particular branch. Okay. Now you can apply what? Current division rule, that's all. Apply current division rule. I equal to, supply current is 20 by 3 into opposite arm resistance, that is 12, divided by sum of the resistors, right? 12 plus 28, sorry, 12 plus 28. So here you are getting 3 4 times, then 20 into 4 divided by 28 plus 12, that is 40. So here 0 is getting cancelled, 4 is getting cancelled, you are getting 2 ampere. Yes, once again same answer. Okay, in this way we can solve by using Norton's sequence circuit. Okay, in order to find out Norton's sequence circuit, you can find the Norton's current, that is nothing but short circuit current. After that you can find the Norton's equivalent resistance, or one more approach from your Thevenin sequence circuit. By using source transformation technique, we can get Norton's current is nothing but VTH divided by RTH, just by using the Ohm's law. Okay, VTH value how much we got? We got 80 volt, right? 80 volt divided by RTH we got RTH, RN both are same. While you are applying source transformation technique, the internal resistance of the voltage source and current source both should have same value, right? RN and RTH both are same. Okay, next here RTH value is 12, so 4 3s are 12, 4 20s are 80. So that means you are getting 20 by 3 ampere. Yes, exactly same. Okay, so in this way, whenever in the question if they ask you that find out the Norton's equivalent circuit, first you can find out the Thevenin's equivalent circuit, that means VTH and then RTH, RN both are same. VTH, RTH just perform the division, from there you are getting the Norton's current or short circuit current. Okay, and I have discussed another method also, directly you can perform you can short the terminus, from there you can find out in that particular short circuit path how much current is flowing. In this manner, whichever way or whichever method is convenient for you, you can solve the given question accordingly. Okay, but ultimately the motto is very simple, you should get the answer quickly in less time. But since I am mentioning that quickly, don't do in hurry, because if you are if you are in the fast mode, then definitely there are the chances you may be doing the silly mistake. But please be alert, please have the patience, but by following whichever method you can get the answer quickly, definitely can apply that particular method. Okay, so for this particular, like if you observe from question number 11 to question number 17, that means total 7 questions, right? Total 7 questions I have considered the same circuit, and we are finding the current flowing through the 28 ohm resistor, right? Have you ever thought for this particular question or circuit we can solve in 7 methods? Have you ever thought? We have discussed in 7 methods for the same circuit with the help of whatever the methods that you have learned in the first chapter and what are the theorems you have learned in the second chapter. Whichever methods and theorems are possible for solving this particular question, we have discussed each and every method and theorem here with the help of this particular question, right? So all of you can share your experience in the chat, and whoever feel, sir, this question we can solve in one more method also. If you feel like that, you can mention the name of method in the chat. Definitely I will be appreciating there. Okay, whoever watching this particular session later, you people can mention like in the comment section, like question 11 to question 17 or any one question number you can mention, sir, and then you can mention the name of method. If you feel that we can solve this question in one more method, okay, I will appreciate those students there in the comment section as well. Okay, I hope all of you like this question like anything, right? So in this way, when you are solving any question, not only in this subject, in any other subject, like try to solve in whichever methods possible, and then you can decide among those methods which one is the best method for that question. Definitely that method, if you are able to apply, with the help of that, you can easily, you can easily attempt the question in less time. But understanding point of view, whichever methods possible, do all the possible methods so that concept wise you are getting the deep learning. Okay, right. Now the next question regarding maximum power transfer theorem. Okay, so here you are having the load resistor RL. In order to get maximum power across it, what should be the RL value? Okay, I hope all of you familiar. Whenever we want to get maximum power transfer across the load resistor, RL is nothing but RTH. See the beauty of this question. We are using maximum power transfer theorem condition, but in order to find out RL value, once again we are using what? RTH. That means when you are supposed to find out RTH, once again the question belongs to the previous theorem, that is Thevenin's theorem or Norton's theorem, in order to find out the equivalent resistance. Okay, right, fine. And here you can observe, like whatever the load resistor here you are having, you have to remove the load resistor value from the circuit, then terminus will become what? Open. Across the open circuit terminus, you have to find out the RTH, right? Earlier question, if you observe, earlier question and this question, what is your observation point? All of you can mention with respect to the type of sources present in the given circuit. With respect to type of sources present in the given circuit, what is your observation point after removing the load resistor? There we have removed 28 ohm resistor, like that here RL after removing. Earlier question, you are having current sources and both the current sources are independent, but here you are having voltage source, that is the independent, but here also voltage source, but this is the dependent source. Whenever you are having combination of independent and dependent, or when you are having only combination of dependent, okay, those questions you can solve by using one method. That method name I am keeping suspense. Before that, okay, before that, let us solve this question in the conventional approach first, and then I will be discussing that what the other method. Okay, right. Now just observe, first of all, here you are removing the load resistor, then terminus become open, right? So you can find out VTH and then you can find out the short circuit current. After that you can take the ratio. Just simple logic. Across the terminals you are finding the voltage, that is the VTH, and across the terminals you can short it. Okay, you can short it and you will be getting short circuit current. After that you can take the ratio of both, that is nothing but VTH divided by short circuit current, that is nothing but what? RTH, that's all. Okay, so see, even here also we have discussed VTH divided by IN is nothing but what? Short circuit current, that is nothing but RTH only, right? First I am discussing this approach, after that I will be discussing the shortcut method. Right. So here first of all we have to find out the, we have to find out the open circuit voltage here, that is VTH, and then you can short the terminals here. You can short the terminals here and then you can find out the short circuit current. Okay, when you open the terminals you are getting the voltage. Okay, when you short the terminals you are getting the current. After that you can take the ratio of both. Okay, VTH and short circuit current, that is nothing but RTH. RTH equal to VTH divided by short circuit current. Okay, all of you give a try. For the time being, I am mentioning this particular question as homework for everyone. Okay, all of you give a try. We'll discuss this question in tomorrow's session. Okay, I hope all of you understood how to find out the open circuit voltage, how to find out the short circuit current, because we have solved in the previous question, right? So you can do it, and after that you can just find out the ratio of those two. From there you are getting RTH. Okay, and the second method is test source method. Okay, whoever already solved good number of questions by using test source method, accordingly you people can give a try. Okay, but I am keeping suspense how to solve the question by using test source method now, but I have given the hint in which method you can solve this particular question, right? That is the test source method. So for the timing, this one also I am giving as homework for everyone. I want to cross check in tomorrow's session, like how many of you are able to get in both the methods correct answer. Okay, this also I am keeping as a homework. Okay, right. So in the last question, we are supposed to find out the RL value. That RL is nothing but what? RTH. Okay, just for reference here I am mentioning RL is nothing but RTH. In order to find out RTH, two methods are there. One method is VTH and then short circuit current, take the ratio. Other method is directly you can get by using test source method. Okay, whoever having good command over test source method, those students can try. And for last question, okay, in method 1 and method 2, definitely the final answer will be same, but whoever solved this question in first method, they can mention VTH value and short circuit current and then RTH or RL value. Okay, but whoever directly solved this question by using test source method, directly you people can mention RTH value or RL value in the comment section. Okay, comment section of this particular video. Or whoever attending on tomorrow's session in the live session, in the beginning of tomorrow's session, we will be discussing this question. Okay, so that time you people can mention, whoever attending live session, those students can mention the chart. Whoever not, due to any reason, whoever not attending the live session, those students, for the last question, you people can mention in the comment section of this video only. Okay, whoever able to get the correct answer, definitely I will be appreciating. And whoever getting wrong answer, no issue, you can attend the tomorrow's session, right? Or you can watch the tomorrow session whenever you get the time. Okay, so in this particular session, we have discussed the variety of questions regarding network theory subject regarding first chapter and second chapter. The first chapter is related to basics, that means basic laws and then basic methods, and then second chapter network theorems. Okay, so in tomorrow's class, we will be discussing, yeah, all of you can share whatever the experience you got from this particular session with the help of whatever 17 questions we have covered. 18th question I have given as a homework for the time being, but I will be covering in tomorrow's session. Okay, but till then you can try, you can consider that is a homework question. Okay, right. All of you can share your experience in the chat or comment section. Okay. So tomorrow also, as I mentioned multiple times, we are having the continuation session regarding network theory subject, second session. Okay. Timings you can get the, like you can see in our YouTube channel, when you click on already the bell icon regarding our YouTube channel, whoever subscribed our YouTube channel and then clicked on bell icon, definitely you will be getting an instant notification. So whenever when the live session is going to happen. Okay, so you people never miss whatever the upcoming live sessions are happening in our YouTube channel. Okay, so in tomorrow's session, we are going to discuss the last question of this session, that is the 18th question, and then the remaining questions related to the last 3 chapters, that is two-port networks, and then transient analysis, and then steady state analysis as well, right? So definitely all of you will get, with the help of this session and tomorrow's session together, you people will get maximum benefit regarding network theory subject. And whatever you people attended before attending these sessions and after attending these 2 sessions, you people can cross-check your confidence level, and in terms of knowledge or in terms of method of solving or in terms of avoiding silly mistakes, each and everything you people can do self-evaluation, and you people can mention your valuable experience that you got from today's session and tomorrow's session as well in the comment section. Okay, right. And not the least, okay, as many of you are attending, sir, where we can find whatever we have discussed during our live class, this particular notes, especially in our YouTube channel, whatever we have taught during the live session, right? This particular notes we are sharing in this particular Telegram channel. This is our IMS GATE Academy Telegram channel. Regarding the link already provided in the description of this particular video. Whoever not yet joined our Telegram channel, kindly join, so that you will be getting, whenever we are conducting upcoming live sessions, that schedules you are getting the update, and whatever faculties have written during the live session, that particular notes also we are sharing right immediately after the session getting over. Okay, right. And you will be getting all these important updates related to whenever we are conducting seminar or webinar, and all the other important updates also you are getting here. So it is free for everyone. All of you can share this valuable information with all of your friends as well. Okay, and so in this particular session, the kind of questions that you people got, it is amazing, right? So I hope all of you got excellent experience from this particular session. Like this, that is the most important. Whoever aspiring to write the GATE 25 exam and whoever not enrolled at our IMS GATE Academy, for all those students, I am strongly recommending to enroll for our Test Series Plus program, so that you will be getting all these benefits, right? So you are getting 130 plus online tests, and then GATE previous year question booklet along with the detailed solution, and all these features you are getting whoever enrolling for Test Series Plus program. Currently 20% offer is running, so it is a limited time period offer. So regarding the Google form, for enrolling this particular program already provided in the description of this particular video. Kindly do it on immediate basis. Okay, right. Yeah. Thank you everyone. We'll meet you all in tomorrow's session. Okay. So currently aptitude class is going on in our YouTube channel. Okay. So all of you can join that particular class. Okay, right. Thank you everyone.